Hi, Addy. Welcome to lesson number 89. Today's lesson is going to be awesome. Okay, I can't wait to get into it with you because we are going to learn how to estimate square roots. This is where math really starts to get hard, but you are prepared for it. You are ready. This is where you're at, and you can do it. Okay, first, let's look at this mathematician food fight. Look at the mathematician food fight. These guys are all mathematician, and look what they're throwing at each other. Pie. It's a great, this guy got it right in the face. This guy's picking up a pie off the floor. There's pie on the wall. There's pie on the chalkboard. Okay. All right, let's get ready to do your facts practice. And today you're going to do linear measurements. I know those can be tricky. And don't forget to also correct that when you're doing your correction for today. Okay, so let's jump into it. You're going to have 5 minutes to do it, okay? I'm going to put on some nice music. On your mark, get set, go. Oh, this is a good one. Okay, let's stop it right there. And let's get back into the lesson. Okay, you might need a little break. If you do need a little break, go ahead and pause it after all those linear measurements because I know that those can be really tricky. So take a little break if you need to, okay? The next thing we are going to do is we're going to do mental math, and we're going to count up and down by threes between -15 and +15. And you know that I need some help on these, so I like to make a little, number line and start with -15. I don't know if it would be this one. I'll just guess if I did this right, and +15 over there. And so let's figure it out while these guys are dancing, okay? And we're going to count up and down by threes. So that's a little tricky. All right, we'll start with -15, -12, -9, -6, -3, 0, 3, 6, 9, 12, 15, 12, 9, 6, 3, 0, -3, -6, -9, -12, -15. Woohoo! We did it! Okay, that was fun. Let's do the rest of mental math, and you are going to look at some pictures of, I don't know what, crazy ponies? All right, let's jump in. The first one is 90 times 90. So remember how I like to do these. Take this first number, 9 times 9, you're going to get 81. And how many zeros are there? 1, 2. So let's add 2 zeros. Okay, sweet. And the next one, let's do B. What is 1,000 minus 405? Write your answer. I would do 1,000 minus 400 because that's easier. And then I would maybe say I didn't subtract enough. So what if I subtract another 5? But you can do it whatever way you think is easier. What is 6 times 7.99? For sure on this one, I would do 6 times $8. And then whatever answer I get, I would think, okay, I multiplied too much, so I need to subtract out of that a certain number of pennies. How many pennies? One for each group, right? So it's going to be minus 0.06 or minus 6 pennies. All right, and then D. Let's see if you can double $27. What do you get if you double it? Okay, E, this is a long one. Ready? We are going to start with the number 3 times 3. Then we're going to add 2. Multiply by 5. Subtract 5. Multiply by 2. Divide by 10. Add 5. And then divide by 5. All right, H. We are going to estimate about how many meters tall is a classroom door. So think about that meter stick that I have. And think about a person, like how tall is a person compared to a door? And what would happen if you sort of held that meter stick against your body? Like how tall would that be, you know? I don't know. You can kind of estimate. All right, Houston, we have a problem. Houston, we have a word problem this time. Okay, ready? Here we go. The perimeter. So remember what the perimeter of a rectangle is. That's when you add up all the sides, right? So x plus question mark plus 27 or 21 centimeters. Okay, so the perimeter of this rectangle is 1 meter. So I'm going to write that down. Perimeter equals 1 meter. And that's in units of length. So what that means is if you took this, whoops, oh my goodness, I didn't even know I could do that. I meant to kind of like turn it sideways and like flatten it out, and turn this one sideways and flatten it out. And then you'd have to take this length on top and kind of add it to one of the sides. If you flattened it out and added up all the lengths, that's the perimeter, right? So anyway, but I think you already know what that is because we've gone over it and you know it. So if the perimeter is 1 meter, what is this length? Ooh, that is tricky. It's tricky in a couple ways. Let me tell you why. This is centimeters and this is in meters. So first you have to know how many centimeters. Remember, centimeters. Centi means 100, kind of like 100 cents makes a dollar. Centimeter. So you would already have to know how many centimeters are in a meter and change one of the units. So instead of being 1 meter, maybe this is like, I don't know, whatever you get. Whoops. Oh, okay. And then you have to say, you know, this plus this. Well, it's a rectangle. It tells you it's a rectangle. So you know this side is the same as this side. Okay, so you know that. So if you add these together and then take it away from 100, then you're also going to have to divide it in 2 because this is 2 sides, not just one side, just to get the x. Okay, this is crazy. You figure it out. Let's see if you can do it. If you have any questions, text me. Okay, and let's move on to the new concept. You're going to definitely need to pause it there, but we'll go on to the new concept. So basically, we have been finding square roots of perfect squares up to 100, and that's what we've been doing. So remember what a perfect square is? It's like if you have 100, what's the square root of it? Well, it's 10 because it's 10 times 10. And if you have, so that's a perfect square. And it's a perfect square because if you literally have a square, the way that you find the area of the square is you multiply like 5 times 5. And then you get the area, which is 25 units. And the number 25 is a perfect square. So anything that you can do, that you can make a perfect square out of, like, you know, 6 times 6, and 36 is a perfect square. So all the perfect squares are like 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 36. You already know these. And so when you want to find the square root of these, it's super easy, right? Because you can do square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, square root of 36 is 6. Okay, but what if it's not a perfect square? What if it's one of the numbers in between? Like 3. What is the square root of 3? Oh my goodness, you've never thought of that before, huh? So what if, like, what that would mean, like in this example, is with the square, is the area of the square is 3. So what is this side and what is this side? So what times what is equal to 3? Ooh, that is tricky. And there's a way to do it. One of the ways is called the guess and check method. And here is, I think that's actually Lucy dressed up to look like Marilyn Monroe. Do you think? I think it is. You tell me what you think, okay? All right, here we go. This is, I know you're nervous. You're munching nervously. Nervous eating. Okay, example 1. It says to simplify the square root of 400. What the? This seems crazy hard, right? So we're going to do the guess and check method. So something times something is equal to 400. Remember, because if you have a perfect square, let's actually, yeah, that's okay. If you have a perfect square, you've got something here, one of the lengths, something here, and the area is 400, which means x times x is 400. What is x? And x is going to be the square root of 400, but we have to simplify that. Okay, so how do we find the square root of a number if it's not a perfect square? You have to just start guessing, okay? So what you do is you say, well, I know that 10 times 10 is equal to 100, and that's way less than 400. So these numbers have to be more than 10, okay? They have to be more than 10. So 10 was not right. That was our first guess. Okay, what about if you do, you also know something else. You also know that the square root of 4 is 2, because 4 is a perfect square. So what if you do, instead of 10 times 10, what if you do 20 times 20? So then you get your calculator out, or you do it in your head. No, don't get your calculator. Do that in your head. You know how to do that. 20 times 20 is what? Well, it's like mental math. You do 2 times 2, which is 4. And then how many zeros are we going to put on? 1, 2. So 20 times 20 is 400. Oh, guess what? You just found it. And so just by guessing, you find that the square root of 400 is 20. Okay, sweet. So let's turn the page and we're going to do another example, and it's going to be even trickier. Okay, so this is example 2. Woo, we are going around and round. We've got this, right? But look at this problem. What is the square root of 625? Whoa. All right, this is tricky, and we're just going to start guessing. Now, in example 1, we learned that the square root of 400 is 20. So we know that the square root of this is going to be more than 20. Okay, what else do we know? What if it's 30? Let's just guess 30. What is 30 times 30? What do you get when you do that? So if we start with 3 times 3, we're going to get 9. How many zeros do I add to that? I add 1, 2. 30 times 30 is 900. And that's too much. So it can't be 30. So it's somewhere between 20 and 30. Okay. But also look at something else. There's another clue. And the other clue is that the last digit of the number is 5. It's not 400 is 00. It's not 900. That's 00. So maybe it's not like a number that ends in the tens group. Maybe it's in the middle, like 25. So this 20 is too low. 30 is too high. Let's guess 25. Okay. So if we do 25 times 25, what do we get? All right, let's figure that out. I like to do these problems like this. Okay, so then I do 5 times 5 is 25. And then I do 5 times 2 is 10. Add 2 to that is 12. And then I'm going to do the tens group. So 2 times 5 is 10. So I'm going to do 10. Okay. And then I'm going to do 2 times 2 is 4, plus 1 is 5. Let's add it together, and we get 625. So the square root of 625 is 25. And we just did it with the guess and check method. If you guess something that's too low, go higher. If you guess something that's too high, go lower. And then look at the clues. If it ends in 5, it's probably going to be a weird number that ends in 5, not 10. All right. Whew. Whew, this is getting you angry, isn't it? All right, that's okay. We only have a couple more examples. Between which two consecutive whole numbers is the square root of 20? What do they mean by that? That means the answer is not going to be a whole number. It's not going to be 1 and it's not going to be 2. It might be between 1 and 2, like 1.5. But it's going to be higher than that because it's the square root of 20. So they mean it's between two whole numbers, but it's not going to be an exact whole number. So which two numbers is it between? So we're not even asked to find the square root of this. We're asking to find the whole number that's on one side and the whole number that's on the other side. Let's look at our perfect squares. What if we do 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7, 49. I went way too far, but that's okay. These are our perfect squares. So where is 20? 20 is between the 16 and the 25, right? It's going to be, it's going to be somewhere here between this and this. Now the 16 happens when you do 4 times 4. The 25 happens when you do 5 times 5. So if we do our guess and check method, we can see that since it's between these two numbers, somewhere if you have a number line, and this is 4 and this is 5, then the arrow is between 4 and 5, so it's going to be somewhere here. Okay, so we just used reasoning to figure out that the square root of 20, let's make that yellow, is somewhere between 4 and 5. So there must be a number between 4 and 5 where the square root of that is the square root of 20. Let's just pick a number and see what happens. What if it's halfway in between, like 4.5? If we do 4.5 times 4.5, you do your multiplication or use a calculator, you get 20.25. So that's pretty close to 20, but it's a little bit too high. So that means that 4.5 is a little bit too much. So if we had to guess, we would guess a number that's less than 4.5, but it's still going to be between 4 and 4.5. So what if it is 4.4? Let's get out a calculator, do 4.4 times 4.4, and you get the number 19.36. This number is too small. It's not 20. So if this is 4.4 on the number line, we know that this is too small because it's less than 20. This is too big. So the actual square root of 20 is somewhere in between 4.4 and 4.5. But if you're super smart, which you are, you're going to see it's actually a little closer to 4.5. So it might be like right there. If you keep doing this and just guessing numbers like 4.43 or 4. Something like that, then guess what would happen? You would never, ever find the square root of 20 exactly, and you could spend your whole life trying to narrow it down because the square root of 20 is something that has a special name. It's called irrational. And that's why it's irrational. actually wouldn't want to keep doing this process to find the exact square root of 20 because there is no number that it is exactly. You could keep trying to pin it down and you might end up with like 4.4379283. You know, I don't even know what it is, but it would keep going and it would never be exact. It would be like 20.00001 and you'd be like, ah, I didn't get 20 exactly because of that stupid one. But guess what? You would never get 20 exactly, even if you keep doing this forever, because it's an irrational number. But you can say that it's more than 4.4, it's less than 4.5, but you would never find a decimal number or a fraction that's exactly the square root of 20. And that's the definition of an irrational number. An irrational number. What's happening? Irrational usually means like, you are crazy. You are so irrational. You know, it's kind of like an insult that means like you're not thinking logically or you're not thinking clearly or rationally. You're being irrational, like not rational. So it turns out that irrational means it can't be a ratio. In other words, it can't be a fraction. Something over something. You can't say it's equal to 1/3 because 1/3 is like, well, let me not go there. Sorry, let me not go there. But 1/3 is a number that goes on forever, right? It's like 0.333333, and you'll never get it exactly. But it's not an irrational number because it's exactly equal to 1/3. So you can express it like a fraction and you'll get that. And even though it goes on forever, it's still rational because you can express it as a fraction. So it has to be a number that goes on forever, but also it can't be an exact ratio or decimal. It can't be an exact fraction. So here's some examples of other irrational numbers in this comic. And this kid is saying, so no matter what, you can't make them fractions? Those are numbers I can get behind. This kid obviously hates fractions. So he's like, yay for these numbers. They can't even be a fraction. So we know that the square root of 20 is approximately 4.5, but it's an irrational number. And this wavy equal sign means it's close to, it's approximately equal to. That's what that means, okay? Let's do one last example and then you can get on with your homework. Here we go. It says use a calculator, so you're going to definitely need a calculator here, to approximate the value of square root of 20 to 2 decimal places. Okay, so they want you to use your calculator to figure out the square root of 20. So how do you use your calculator to figure out square roots? Take your calculator. Here's the square root sign. You can either hit square root 2, 0, and then equals, just like this one, square root 2, 0 equals, or it's going to be 2, 0, put the number first, and then square root sign. That's how I like to do it, because once you hit that square root sign, you don't even need to hit equals. It'll just do it for you. And then I can make sure that I have my number correct. So I hit 2, 0, and then I hit the square root sign. That's how I like to do it. And if you do that on a calculator, you'll get this. And it turns out that it just keeps going because you can never get it exactly. This actually keeps going on all the way to infinity. Like even computers can't keep doing it forever because they'll just keep going, right? So the calculator will give you about 9 decimal places, depends on your calculator. And they asked in the problem, they asked you to round it to 2 decimal places. So if we were to round this, that would be this one and 2 decimal places past it. So this. And you decide if you round this one up or down based on the next number, right? So this number is less than 5, so we're going to round it down to 7. So the answer is 4.47. Bam. Okay, cool. And that's it for the whole lesson. And I know you're like, I'm so done. I was done 5 minutes ago. But that's it, Addie. So I hope you enjoyed this lesson. Have fun doing your math today, okay? Love ya. Bye.